I hope everyone has their second wind or third wind for some more afternoon talks. So let's transition now to talking about welfare analysis with less standard policy instruments. So so far we've spent a lot of time talking about taxes and kind of touched on questions. Oh, I forgot recording. I touched on questions about regulation. A lot of the time, though, and I, especially more in kind of popular press and the media, what you see is a lot of discussion around non-financial instruments and ones that are not also kind of bans and hard regulations. So things around kind of social norms provision, how efficient are you relative to your neighbors, various kinds of warning labels, various other kinds of ways to presumably convey information to people. Oftentimes, these kinds of instruments are described as nudges, where I think the presumed definition is that these are instruments that are designed to affect choice without really affecting people's opportunities. I'm not going to use that word. Because as will become more clear as I go through some basic theory and talk more about measurement and what we should be looking out for, I think there are very few, if any, instruments that plausibly satisfy such a definition. Now, alternatively, you might say such a definition is too stringent, but then the question is, what is a proper definition that is kind of intellectually useful for us? So this is what people often refer to as nudges. I'm not going to use that word, just so we're on the same page here. But the kinds of examples that I have in mind here are things like information provision, social comparisons, reminders, various ways of reframing decisions, defaults, which Doug will talk about later, advertising, and so forth. There are various other kinds of notions that I won't touch on much, except in how they relate to kind of concepts of wealth, the kinds of formulas I'll show you in a few minutes, such as libertarian paternalism and asymmetric paternalism. I will also argue that these kinds of notions are not quite what we want when we're thinking about rigorous modeling and measurement. But part of the popularity of these kinds of policy instruments and why they're so often discussed is because there are a number of so-called nudge units, starting with the United Kingdom and the USA, and now many, many different countries, where the idea is to design these various kinds of instruments to achieve certain kinds of goals, and they do often run randomized controlled trials, which is great. Okay. So let's think about, let's start with an economic formulation of how we might think about these policy instruments. And where I actually want to take off is the formula that you already saw from Hunt. Okay, so when we think about the impact of one kind of policy instrument, which is just a simple tax on welfare, and this is the welfare that results from one particular type theta. Again, what do we think about? Well, we think about the corrective term. We think about the impact on revenues through the fiscal externality, so the substitution effect. And then we think about the mechanical effect on consumer surplus and the mechanical effect on government budget. Okay. Nothing I just described about those three terms is such that these three terms really concern only tax instruments, or in fact, only financial instruments, or anything that we would describe as a standard instrument in economics. In fact, consider any kind of intervention of size sigma and consider either amplifying it or making it a little bit smaller. Now, marginal changes in certain kinds of interventions are a little bit unrealistic, but let's just go with this for now, for just thinking about the concepts. It's the same thing. They're really kind of like three things we always think about. We think about what is the impact on behavior and how that generates corrective benefits, or hopefully corrective benefits. We think about the impact on revenue. Now, what might revenue mean here for an arbitrary instrument? Well, there's a few things going on. One is you are getting people to change their behavior. So if there's a tax in place, okay, that substitution is still going to generate similar kinds of fiscal externalities. Two is you might think about other kinds of interactions with other kinds of instruments that are in place and how that might affect revenue through the substitution effect. And then there are similarly mechanical effects. So let's say that we're talking about something like advertising. The more you amplify advertising, the more it costs. That is exactly analogous to what we think about with taxes or subsidies. The higher the subsidy, the more it costs. So it's a similar kind of effect. And then there's a direct effect on consumer surplus. So here I just called it an aversiveness term. It doesn't necessarily have to be positive, it could be negative because certain kinds of interventions might make consumers feel good, but that's directly analogous to how we think about the mechanical effect on consumer surplus, right? If a consumer can generally purchases 5 units of something, you increase the tax by $1, what is a consumer's mechanical aversion to that? It's $5 worth. Okay. Same thing here, except you can think of more generally about the direct effect on consumer surplus. So again, this is just a generalization, and kind of at a high level, you can really think about any kind of intervention this way. And then all of the same questions, the ones that Hunt was talking about before lunch, come up. We want to think about the relationship between treatment effects and bias. So Hunt was just talking about tax elasticities, but more generally, we're just talking about treatment effects and bias and how they relate to each other. We want to be careful about consumers' aversiveness or enjoyment of the intervention, and we're talking about fiscal externalities and costs of implementation. Let me do something a little bit more specific. This was a little bit more general than is helpful. Let's just consider a little bit more of a concrete setup where we have consumers who have a unit demand for a good X, so they purchase it or not. If they get it, they derive utility V sub theta. We have bias. And again, I'm thinking about bias in exactly the same way. We're talking about money metric as the vertical difference between a market demand curve and the demand curve that we have and what we specified as the welfare relevant domain. And we have treatment effects given by tau sub theta, so that post-treatment, consumers purchase the good if V plus gamma plus tau is larger than its price. And the utility they derive is V minus P minus this aversiveness. Without the intervention, they just purchase it if V plus gamma is larger than the price, and the utility they derive is V minus P. We have some producers in the background, and for purposes of what I'm going to talk about today, let's just ignore redistributive concerns. Okay, so what does it look like? So if we have an intervention with treatment effects tau sub theta, in the absence of any other kind of policy, namely in the absence of a tax that we might also be using to try to correct behavior, what are the welfare benefits of this? Well, it's really about the second moment. So think about gamma plus tau as kind of post-treatment bias. It's the extent to which information might have help people make better decisions. And sorry, there's a theta missing here. And this is kind of the pre-treatment bias. So what we're really looking at here is just the difference in the second moments of post-treatment versus pre-treatment bias. And then we have this aversiveness term in the background. And then of course it scales by demand. What is the intuition? Well, the intuition is just the cost of bias is quadratic in the bias. So we're kind of applying a bunch of kind of Harberger approximations, kind of type by type here. And now we're taking the average. Okay, so it's the extent to which the distortion from bias is reduced post-treatment. Okay. Now, if you have a syntax in place and you can set it optimally using the kind of formula that you saw before lunch, okay, that's exactly what's going on in the background. We're setting a tax to equal the average marginal bias. There's a similar formulation for how helpful this alternative intervention is with an optimally set tax, and it's given by the difference in variances now. So we're basically now, we're demeaning everything. So it's kind of the mean second moments that we're looking at, which is intuitive because the tax has to equal the average marginal bias. So you're kind of taking that all out. You're taking out the average. And now we're talking about these, the mean second moments, which are just the variances. Okay, so I will illustrate the intuition behind these equations with some very simple examples. But let me make just one high-level statement now, which is, what is an intervention that produces good behavior change? It's not an intervention that has a large average treatment effect, period. It's an intervention, rather, that has attractive properties in terms of what it does to second moments. And I just want to pause here. So think about all of the nudge papers that you might have seen that are all about average treatment effect, and look at these formulas. It's not about the average of tau. It's about what tau does to the second moment. And it's particularly relevant, or I think this, what I'm saying here, has especially large bite when we're looking at the second equation here, where we're looking at the difference in variances. This is just completely orthogonal to the first moment. You know, here, what we're talking about here, when we're talking about this second moment, this is the variance plus the mean, the average treatment effect squared. So there is a sense in which the average treatment effect enters into this formula, although it's not the same thing. But there's a very profound sense in which the average treatment has nothing to do with the welfare consequences of an intervention, when we can also set the syntax optimally. So these issues are around targeting, roughly speaking, and I'll illustrate this. The second thing, of course, that we have to think about is the extent to which this intervention has direct consequences to people's utility. So when we're thinking about social norms interventions, where you're being compared to your neighbors, you might feel really bad when you learn that you're doing a lot less for the environment than your neighbors are. And even things that are somewhat innocuous or seemingly innocuous, like that food plate that you saw, that might make you feel bad too. Sometimes you just want to enjoy your dinner and not think about nutrition. Information can have very powerful effects on people's experience, and we shouldn't just assume that away. We don't have to assume that it's the case, but it'd be nice to kind of have a framework where we can take it seriously and where we can try to measure it. Okay. So those are the things we really should be thinking about. Beyond just average treatment effects, we need to be asking what is happening to the second moments, and we should be asking what is the direct effect on people's utility from things like I'm feeling guilty, I'm feeling bad, I'm feeling kind of shamed, or on the positive side, I actually feel really proud. Maybe you get this mailer and I learn, wow, I thought I wasn't doing so well in energy conservation, but I'm doing so much better than my environmentalist neighbors. Now I have this nice glow, and that's something that should be taken into account as well. Okay. Let me give you a simple example to make some of these issues concrete. This is a very simple one. Let's say we have consumers purchasing sugary drinks, and either they greatly overestimate they purchase sugary drinks way more than they should because they are oblivious about health costs. Or we have some health conscious consumers who, you know, either they definitely don't over purchase them, maybe they even under purchase them because the health costs are kind of salient in their mind, maybe more salient than other considerations that they should be taking into account. Now, let's say we have a sugar warning label that actually, you know, on average, it does decrease consumption of the sugary drinks. But through what channels? Well, the consumers who overconsume sugary drinks because they are oblivious to health information, you know, there's a reason why they're oblivious to health information, because they ignore the labels like this. So they're not going to react to the label. The health conscious consumers, well, they're very, very health conscious, you know, to the degree that once you re-highlight sugar for them, maybe they become oversensitized. okay? And so they are the ones who are actually reacting to the label. So in the end, what we have is a policy that, in some sense, it seems to move behavior in the right direction because we are in a population that on average overconsumes sugary drinks. And we do have a policy that on average reduces consumption of sugary drinks, but it's terrible. This is a terribly inefficient policy to implement because it does exactly the wrong thing. And where is that reflected? It is exactly reflected in the second moments, because what it does is it only amplifies the difference in the misperceptions of marginal utility of consumption between the health conscious and the oblivious consumers. Any questions? Yes, please.
How much does context matter? Because in the US, we don't have sugar warning labels. So I remember there's like Mexico, I think, is like it's a norm to have sugar warning labels. And so does that does the frame of reference matter for this and how we think about the treatment effect or no?
Is this a question about short run versus longer run effects?
Oh,
you know, or kind of like what would happen if we put in a sugar warning label in the US versus took away the sugar warning label in Mexico? Yeah, I mean, that's a good question. I think short run effects might differ from longer run effects because people might initially maybe react more to the information. For example, if something new happens, you happen to pay attention to it. So maybe the kind of example I'm giving here is potentially more relevant for shorter run effects than long run effects, but I don't know. I mean, overall, I agree that's a good question, and that's something that I think the literature has started addressing a little bit, but we should be thinking about this very hard, in part because I think there's a lot of interesting psychology and economics that would suggest why short run and longer run effects could be different.
And also the intersection with the cultural norms, which is a factor that we haven't even been thinking about yet. So.
Yes. Yes.
Yeah, I'm Mexican, so I know exactly the labels. They recently changed them completely, and now they put so many labels that everybody's like, yeah, of course, this has 5 labels. Like this, like one black symbol for everything that's wrong with the product. So now everything has 4 or 5 circles. Sometimes the product is big, it's not big enough to put all the circles. So now it's like a circle says this one's 5.
I'm going to show you, I think example 3 might capture what is going on. Let me come back to this with my examples. I think you actually have a nice description for motivation for my example 3. Any other comments or questions? Okay, let me do, before I get to the example 3, I'm promising, let me do example 2. Let's now consider a population that is homogeneously biased. And let's say we have an intervention that changes bias to 0. So quote unquote debiases half of the consumers and it does nothing to the other half. Okay. So you might think this is kind of a model asymmetric paternalism or libertarian paternalism. You know, it didn't help everyone, but it unambiguously improved the decision quality of half of the people in the population. Here's my claim with, if you can optimally set syntaxes, this intervention is welfare decreasing. Why?
Well, this homogeneous bias just set the optimal text in exactly what you want to go to, but not
Yep. Yeah, exactly. Exactly. When bias is homogeneous, you can set a tax equal to that bias and you recover the first best. What this intervention did is it generated heterogeneity in bias because now half of the people are biased and half are not. So it doesn't, no matter what you do now with the tax, you will not get to the first best anymore. Okay. And where is that captured? Well, it's captured in, this is a very simple example of why we should be thinking about variances, right? The variance pre-intervention is 0. The variance post-intervention is positive. Questions? Okay, here's a third example, and this is the one it sounds like. Let's say the intervention is in an average sense, actually offsetting the bias. So if you are a consumer with bias of size gamma theta, on average, the treatment effect is going to be negative gamma theta. Okay, so that looks pretty good. But it's kind of confusing, and that's just a conditional average. There's like 5 different labels, and there's basically noise around this. Sometimes some data types will overreact, some will underreact, and the way that I'm modeling this is with this epsilon term, which is mean 0, right? So again, conditionally, there's a sense in which kind of the conditional average of this intervention is really in the right direction, but there's just this noise term epsilon here. Okay. So it almost looks like it's well targeted. So if you're just thinking about targeting from the perspective of covariances, what is the optimal covariance between the treatment effect and the bias, this is kind of as good as possible. However, this intervention is actually welfare decreasing, both when you can use optimally set syntaxes and even when you are constrained to not do anything with taxation, when the variance of this epsilon term is sufficiently high. What is then tuition? Well, then tuition is that this intervention generates more noise in people's decisions than the pre-existing biases did. And I want to pause on this point a little bit, right? Because the welfare costs of bias are not just about an average sense in which people will over or under consume something. A large part of the welfare costs of bias is the kind of noise that it generates in the allocative mechanism, right? So when bias is homogeneous, one thing that we do still have, which is very good, is that the consumers who value the product the most are still going to be the ones purchasing it. So at least conditional on levels, at least conditional on the equilibrium quantities sold and purchased, the allocation is efficient. Once you introduce heterogeneity, you're messing up that kind of efficient sorting. Sometimes you have extremely low value consumers purchasing the product and the high value consumers not purchasing that, and that's extremely bad for efficiency. And so when we're thinking about efficiency, then it's not even enough to think about what is the treatment effect, average treatment effect conditional on bias. You really need to think about the variance of treatment effects as well, because if the treatment effects are highly heterogeneous, and they're highly heterogeneous not just because they're perfectly equal to the negative of the bias, that can be extremely bad for the efficiency of markets as well. And that's what this example is capturing. Okay, so that's kind of an important lesson too. It's not even enough to just look at the average treatment effect conditional on what you estimated the person's bias to be. You need to understand the dispersion. I think that what you described, what you were just describing about things getting kind of confusing and so forth for people is a potential example of how you can have very heterogeneous treatment effects, which is quite bad for market efficiency. Any questions here? Okay, let me quickly say one more thing. So this is, all of this analysis so far has been assuming perfectly competitive markets with effectively fixed producer prices coming about, for example, from a flat supply curve. All of this can be generalized to situations where we have elastic supply, so an upward sloping supply curve, and in fact also imperfect competition. Although here I'm going to assume kind of a symmetric Cournot game in the background here. Now, it turns out that even with all of these complications, this version of these formulas is still recovered. And basically, the new key sufficient statistic we need to have is the pass-through. Okay? What I mean by pass-through is when you increase the tax on producers by 1 unit, what happens to the prices that are being set by producers. Okay. Now, what is the impact of the intervention on prices? Well, now in this world where we don't just have a boring supply curve, the intervention is in fact going to, by shifting the demand curve, it's also going to shift the prices set by consumers. And the extent to which it does so is proportional to the average treatment effect of the intervention and 1 minus the pass-through rate. Okay. So that's the effect on prices. And one thing I just want to pause here on this bullet point is another, I think, extremely obvious to say thing that is, I think, missing, in some sense shockingly missing from discussion of quote unquote nudges. In economics, most shocks to demand affect the equilibrium and therefore affect equilibrium prices. So in that sense, most things are actually going to change opportunity sets. So then again, it becomes very hard to talk about things like libertarian paternalism. You know, a shock to demand that actually has a big impact, that has a greatly increases the prices faced by consumers, doesn't feel very libertarian paternalistic to me in the sense of leaving consumers' opportunity sets untouched. Okay. But, you know, with that in mind, if we instead kind of take standard approaches to welfare, again, building on standard optimal tax formulas, you get formulas like this. And the main thing I want to highlight here is that the lower is the pass-through, then even in the absence of taxation, the more we should be thinking about the impact on the more we should be thinking about the impact on variances rather than just the impact on kind of second moments that involve the average treatment effect squared. Okay. And let me illustrate this point with one more example. So suppose we have a competitive market, but it has fixed supply. So we have a vertical supply curve. Okay. We have homogeneous bias, and we have an intervention that changes bias to 0 for some positive measure of consumers and leaves the bias of other consumers untouched. Okay, so again, by kind of you know, more informal, colloquial type intuitions, we might think this is a great intervention. Definitely improving people's decisions, but my claim is that with and without taxes, this intervention is welfare decreasing. Okay, so forget optimally set in taxes. Even without any other kind of intervention, this is an unambiguously welfare decreasing intervention, despite reducing bias for potentially very large fraction of consumers. Why? Just fixed supply. So what that means is that bias does not affect the equilibrium quantity sold and purchased. Okay, that's kind of the key thing about this example. So given that, and again, recall what I was saying about noise in the market. Yes.
Well, basically, I mean, now the consumers who don't have bias are going to buy less of it, but the ones who do are going to buy more of it.
Yeah, exactly. It's before we were actually first best. With fixed supply, homogeneous bias is not actually bad for welfare, does nothing. The thing that's bad for welfare with fixed supply, it's all about the variance of the bias. It has nothing to do with the mean level of the bias because again, the quantity purchased stayed constant. So mean shifts in consumers' perceived marginal utility don't actually do anything. Rather, what affects efficiency is the sorting. It's as soon as you introduce variance and bias, that's where you get to a situation where sometimes you have consumers with lower values purchasing the product, but consumers with higher values not. Okay. And so again, and this has to do with what I was saying here, the pass-through is really low. It's all about the variance. And this is a variance increasing intervention, and it is unambiguously bad for market efficiency. Yes.
Thinking about this example and example number 2, right? If you think in reverse engineering, so there's a chance that it's better to bias the people that have no bias, probably less costly than trying to unbias the biased people.
I did not quite follow. Could
Let's
you?
say half people are biased and half people are not. Then we start from the end, like from the bottom.
Oh, I see. So we start with heterogeneous bias, and now you're
Exactly.
saying maybe there exists welfare improving interventions that actually increase bias, and we do that by making that
Bring everyone
exactly.
together.
So that
You
is an
cannot
implication.
bring the bias down, bring everyone to the bias level.
Yes, exactly. That is an implication. Yes. Any other comments, questions? Okay. Let's talk about measurement. So when I say targeting, what I mean is let's set aside the aversiveness term for now. I'm going to have a whole section on how to measure this direct utility effect. Let's talk about measurement of the second moments. So this is coming from work in progress. Help us improve it. So what we did is we measure kind of the targeting of health information and fuel economy labels. We have separate approaches to measuring bias in these. These are two different applications, two different experiments. So in the sugary drinks application, we basically follow the approach that you just learned from Hunt before the break that we used in the syntax paper to get estimates of bias. In the fuel economy experiment, we have it set up such that we can measure it very, very directly. So it's more stylized and more artificial, but without going into it because of time constraints, the measurement there is actually very direct and I think less contestable than the kind of bias measures that we produce for the sugary drinks application. But I'm going to set that aside in the interest of time. So here's what it looks like for the sugary drinks application. This is kind of, there's two things going on. So first, we collect the bias proxy, so the self-control and the nutrition knowledge, as well as health preferences and everything else we need to implement the kind of strategy that we take in the sugary drinks paper. Then we let some time pass by, so 2 days, and then we invite those people back and they do a multiple price list, okay? And that's the baseline multiple price list. Then there is either a control where nothing interesting happens, or people encounter one of 3 different kinds of labels while they do the second MPL. Okay, so again, the control group also does the MPL, but they don't have a label. So here's an example of labels. Here's a nutrition label treatment, okay, which really just highlights the calories as people, and then there's an MPL where they choose between the sugary drink and an alternative that is somewhat similar, but does not contain sugar. And again, it's a multiple price list where we're looking for crossover points. Here's a stoplight warning label. These, I believe, have been, I think, the average treatment effects of these have been pretty high based on public health research. And here's another warning label about how drinking beverages with added sugars contributes to obesity, diabetes, and tooth decay. Now, again, I want to highlight, when you look at labels like this, you can imagine how this can make someone feel really bad. You know, imagine looking at this and drinking that Pepsi. It's not a very pleasant experience. And we also have a component in the study where we measure aversiveness. I'm also setting this aside in the interest of time because I think the other studies I'm going to talk about for measuring aversiveness are a better use of the limited time that we have here. But just keep this in mind, we're not completely ignoring aversiveness, and this is a good example of why we should just intuitively, why you might think it's a real thing. Okay, so what is going on here? So first of all, labels change behavior. So we're talking about willingness to pay here. So this is relative willingness to pay for the sugary drink as opposed to the sugarless alternative. And all three of these labels decrease willingness to pay. And the graphic wording label has the biggest average effect on decreasing people's willingness to pay for the sugary drinks. Okay. So again, the average treatment effects, and I know I'm being a little bit mean to prior literature here, but a lot of the prior papers would just stop there and kind of pat themselves on the back. We decrease people's willingness to pay for sugary drinks, which we presume are bad. Okay, but let's actually look at targeting. These interventions are not really that well targeted, right? So what we might hope for is that the people who are more biased are the ones who respond more. And that's not what we see here. So here, this is just a simple illustration with the median split where we have below median bias in blue and above median bias in red. So what you would hope to see is that the red is way below the blue, but you really don't see that. It seems like the treatment effects here looks like they're approximately uncorrelated with bias. And so what does that tell us about the nature of this intervention? Well, it's basically like an inferior version of a tax, right? Because the treatment effects of a tax are by definition uncorrelated with bias. It's that kind of blunt policy, as Hunt was talking about. And again, recall treatment effects here are in price space. So the treatment effects of a tax are by definition here homogeneous. Okay, so a tax is similarly uncorrelated with bias. But recall also what I told you, the variance of treatment effects, after you think about the covariance of the treatment effect with bias, holding that constant, the variance of treatment effects is bad. And as you might intuit, for an intervention like that, there is going to be a positive variance. So this, just looking at figures like this, what we see is this is an inferior version of a tax. It's just this blunt, but it introduces more noise. Now, in the absence of a tax, because the average treatment effects are still quote unquote in the right direction, and it's not like extremely poorly targeted, these interventions still improve welfare, although, and that's in the blue, although they wouldn't do that as much as an optimally set syntax would. In the presence of an optimally set syntax, these interventions decrease welfare. And it's for the reasons that I told you. All that matters is the impact on the variance of bias. And these interventions do not decrease the variance. They actually increase it because treatment effects are heterogeneous. They're just uncorrelated with people's biases. So this is a very useful lesson here. Again, what I want you to remember is treatment effects are in the right direction. In the absence of any kind of regulation, the effects on welfare are moderately positive, although they are not as high as what we would get from an optimally set tax. And if we alternatively can have sugary drinks taxes that are set at the right level, we definitely do not want these kinds of labels. They are just making things worse and less efficient. Okay. Any questions here, comments? Yes.
Can you remind me how you're measuring the bias below and above the bias?
Where do the measures of bias come from?
Yeah.
So we elicit the same kinds of proxies that we elicited in the sugary drink.
Knowledge.
Exactly, health knowledge and self-control. And for each person, once we get a measure of those proxies, we use the mapping that we have in the syntax papers to transform those proxies to a measure of bias. Again, it's the same concept that we've been talking about before as the vertical difference between market demand and demand that would result in the welfare relevant domain. So again, bias here, everything here is in price space. Bias is marginal utility, so it's kind of in people overestimate by X dollars per unit. Treatment effects are also in that same price space here.
So here you are either doing the non-price intervention to all of them or no one. Can we think about another environment in which you, in this environment, you know the prior intervention bias, so you can say, I only conduct the intervention to the the top 10% of both sides? And how will
Yeah,
that affect
well,
it?
that's great. I mean, so certainly for labels that you need to put on the
Yeah.
cans, that's not going to work. Now, there's an interesting consideration here. So you could ask the same question incidentally about taxes. Can we practice something like price discrimination with standard policy instruments? And maybe what we might consider is somehow it's more politically palatable to discriminate using non-financial instruments than it is to discriminate using financial instruments, which then might give non-financial instrument a little bit more of an advantage because it gives you kind of a mechanical way to up their targeting relative to what you can do with something like taxes. So maybe, I don't want to, it's an interesting thing to think about. I'm not sure it's that much more politically tractable to target non-financial things as opposed to financial things, but that it is an interesting consideration.
Can I follow up on that?
Yes.
How are you thinking about incidence of taxes in this context here? So, like, because you've been so critical about this in the 2019 paper, knowing that the incidence would be mostly on low income. So how are you?
Yeah, so here so I suppose like you said, I'm ignoring the distributive concerns, so we're talking about a pure efficiency framework here. There is an additional interesting consideration, and this comes out of the Farhi Quebec's paper, which is that it depends a little bit on how you think about aversiveness and how you model the effects of that. But an additional potential benefit, but it could also be a cost of the non-financial instruments is that they might be less regressive. In the sense that taxes are additionally regressive. When you think about taxing sugary drinks, you might think there's something about the warning labels that is less regressive, but it really doesn't have to be that way. Because again, I want to apply the same standard considerations. Let's say that the sugar warning label, its treatment effect is $1, just like $1 or whatever, no, that's too high. It's 20 cents on the can, just like a tax that is 20 cents on a can. So we're talking about money metric, plus noise. Now we still apply the social marginal welfare weights in the same way. So in that note sense, the intervention is just as regressive as the tax, but then it introduces noise and is less effective. Now, on the other hand, what would actually make it less effective in terms of, I'm not just talking about treatment effects, I'm talking about aversiveness in this. So let's say aversiveness is correlated with treatment effects. So if it's strongly correlated with treatment effects, the thing that would make the aversiveness terms less regressive for this intervention is if the treatment effects on low-income people were also lower than they on the high-income people, which is not good either. Alternatively, of course, the good world is one in which the treatment effects and the aversiveness effects are kind of delinked. So we have this idealized intervention that has very large effects on the behavior of low-income people. It doesn't have a large aversiveness effect on low-income people, and that kind of makes it distributionally advantageous to the tax then. But again, the presence, I guess the main point is the presence of redistributive concerns, again, does not somehow mechanically skew things towards us preferring non-financial interventions. It's just an additional consideration that in some cases might make us like them more, in some cases might make us like them less. Yep. I think there were there was at least one other hand. Did you have did someone else have a question?
So I guess related to
Yes.
these, like the comparison between the non-price intervention and the tax, is there some implicit assumption here that the tax is like you said, as uncorrelated, but like doesn't that depend on the elasticities as well, or is it only that we need the bias to be the effect of the tax of the bias?
No, the elasticities matter too. It's just that when I'm talking about treatment effects, I'm always talking about treatment effects and how they affect willingness to pay, right? So $1 tax in essence lowers willingness to pay by $1. So that's the sense in which the treatment effects of the tax are homogeneous. That's what I was trying to convey here. And the reason I'm talking about treatment effects here and I'm converting them to price space instead of talking about kind of the horizontal difference feeding demand curves is because I want to make apples to apples comparisons. We always have a vertical measure of bias, right? Because that's an interpretable quantity. You know, once we go horizontal, it's what Doug was saying at the beginning. You know, if you just define it as somehow just the difference between utility functions, then it's, you know, not a very meaningful thing. As long as we're keeping it in price space, we kind of have a single benchmark that we're always holding constant. So we always want to think about bias that way. And then when we think about treatment effects, we want to do apples to apples comparisons. But yes, of course, elasticities still matter in the same way that they matter for taxes, they're going to matter for these other kinds of interventions as well. All of the same, if there's one thing you remember, everything we do for taxes, we need to do for any kind of policy instrument. Don't just call it a nudge and say we're doing libertarian paternalism. Everything we do for taxes, we need to do for all policy instruments. Okay, very quickly, when we did fuel economy labels, it's basically the same story. They move willingness to pay in the right direction. So average treatment effects are quote unquote in the right direction. They're uncorrelated with bias. And so again, what we are in a situation is, so we kind of have the variance of the treatment effects and the covariance with bias. And you can see here how higher variance is going to lead to lower welfare effects. And again, you can see here when we're talking about the dashed line versus the solid line, in the presence of a tax, these kinds of interventions are welfare decreasing, even though in the absence of a tax, they're basically an imperfect substitute for the tax, so they have a modest positive effect on welfare. Let me quickly talk about measuring these kinds of aversiveness effects. So a common approach here is an avoidance design. What is people's willingness to pay or avoid willingness to pay to avoid or receive one of these kinds of interventions? There are a variety of applications of these kinds of avoidance designs, although we have to be careful. So if you recall what Doug was talking about in the morning, there's a strong set of assumptions that we need to make for these kinds of avoidance designs to properly price out the direct welfare effects of these interventions. You know, if we're thinking about something like, I'm just going to pick on you, instead of picking on my own paper, you know, if we're thinking about something like home energy, I'm going to defend my paper. We're thinking about something like, you know, home energy reports. You know, let's say they operate on behavior by, you know, making people feel kind of bad about not conserving enough energy. Okay, and now someone comes to you and says, hey, here's this thing that is going to motivate you to conserve more energy by, you know, potentially making you feel bad if you don't conserve enough energy. Do you want to try to avoid this thing? It's kind of uncomfortable to say, you know, if you're the kind of person who experiences guilt from this intervention, it's similarly uncomfortable to say that you want to avoid this intervention. So that's kind of what I mean by the non-comparability problem in this context. Doug already covered the applications to kind of sharing and guilt, so I just wanted to illustrate it in yet another context. So we have to be careful, you know, but we need to start somewhere. You know, we always make assumptions, and certainly these kinds of avoidance designs give us a lot of information. You know, and I kind of picked on a particularly bad version of this, but if a lot of what's happening with these labels is perhaps more about information provision, with information actually generating kind of real utility for people, then some of these issues with non-comparability problems might not be so relevant in this context. So that's kind of the good version of this. So what Hunt and Judd did in this paper, so they're studying these home energy reports, and there's been, you know, after Hunt's 2011 paper, there's just been a huge proliferation of papers that do versions of these kinds of social comparisons, showing that they do have, you know, relatively large effects on people's energy use. This is kind of an example of one. And then what they did is they treat this as a good, and there's a multiple price list that elicits people's willingness to pay to receive these kinds of home energy reports. Okay, so you're just pricing it out. It's very nice, very direct design. Took a lot of, you can talk to Hunt. My understanding is this was enormous effort and a lot of work, but it's very cool to be able to implement something like this at large scale. So you get a whole distribution of willingness to pay. For some people it's positive. So you might think of this as people valuing kind of the informational component. These things are maybe teaching you how to conserve energy better. Some people maybe really like them because they, just the off chance that you might be better than your neighbors just gives you so much utility. And some people don't want them. So there are also negative willingness to pay values. And then on average, and here's kind of a graphical illustration of cost benefit analysis. So once you have these willingness to pay, we can go back to doing standard cost benefit analysis. There's the costs, which include retailer revenue loss and implementation costs. There's the benefits, which include externality reduction. And on average, this willingness to pay is positive. And what I take away from this figure is the importance of measuring these effects. Because if we thought that that mean willingness to pay was 0, then it looks like the costs outweigh the benefits. Once we incorporate it, we have the benefits and the costs stack up against each other in a different way. Comments or questions here? Any supplementary comments?
What a great paper.
Yeah. Yeah.
How do you make sure you're not double counting on the willingness to pay? Oh, I see, this is extra, not.
Yeah. Anything else? Okay, so let's talk about a related paper, which is work I've done on social image. And Hunt, this is your turn to pick on me. So go for it.
Also a great paper.
That's not picking. Okay, so we have kind of two sets of experiments here with social image. One is using social image to in a field experiment that promotes attendance to the YMCA. The other one is social image to promote charitable giving in kind of more controlled online experiments. Here's the social image treatment. This is what, I don't know how we convinced the YMCA to this, but they let us do this, which is basically for anyone enrolled in this study, what would happen is at the end, they would receive basically an information table like this, which lists everyone's names if they were in the social image treatment, the number of times they visited the YMCA, and I should say the reason there's dollars raised is this was kind of part of, it was labeled as a component of this kind of Grow and Thrive pilot, where every time people attended the YMCA, an anonymous donor would contribute $2 to their local YMCA branch. Okay. So, the image motivation here is twofold. Maybe you want to seem kind of like a healthy person who comes to the gym regularly, or maybe you want to seem like a person who really took this kind of additional charitable incentives seriously. Now, what we did on top of this, and again, I'm not giving you a very detailed explanation of the design, okay, but roughly speaking, most people were exogenously assigned to either be in the social image arm or not. So if you were not part of this, okay? But for everyone had a chance to affect the likelihood. They could affect it a little bit, and we elicited willingness to pay this way to basically increase or decrease your chance of being assigned to the social image arm. Okay. So it was really a change in probabilities. The way that we did it, though, is the results I'm going to show you are going to be, you should interpret this as willingness to pay to either be in the social image arm with 100% chance or 0% chance. So there's a design trick that allows us to do this rescaling, even though really it was kind of what we're talking about is increasing or decreasing the likelihood of being in the social image arm. But the kinds of questions we also used as a strategy method style elicitation. So instead of just asking people, what is your willingness to pay to be in the social image arm, we did this in a contingent fashion, okay, where we elicited willingness to pay if people thought that they would attend 0 times. We elicited willingness to pay if they would attend once, twice, and so forth. So the final randomization was actually done at the end after we could observe people's attendance. Now, the reason this is important is we know that people misforecast their behavior. So it could be problematic. We would get potentially very upwardly biased estimates of the direct effects of social image if we're in a world where everyone thought that they're going to go way more than they do and therefore derive a lot of positive image. The other thing that makes the strategy advantageous is now we get multiple data points per person. And so we have a lot of data to really plot out what these kinds of social image incentives look like for different levels of attendance. Now, before I show you that, first of all, again, there's this standard question of what is the average treatment effect, and the answer is it's positive, and it was actually quite large. So the social image intervention, and this is just using the exogenous assignment to the majority of the people, it increased attendance by about 1.2 visits off of a baseline of 6.9. It's a big effect. But what do the welfare effects look like? Well, what our elicitation method allows us to do is basically plot out action contingent or kind of signal contingent demand curves for social image. So what I'm showing you here, just in this plot, is just 2 demand curves. So one is, what is the demand curve for social image conditional on attending the YMCA 0 times? And the second one here is, what is the demand curve for social image conditional on very high attendance? So you can see a large outward shift, meaning that social image is a much more desirable good when you have high performance. Okay? So it's standard interpretation here. And in fact, again, as I was saying, what our elicitation method allows us to do is produce a demand curve for kind of all possible sets of attendance. Now, once we have demand curves, we integrate to get consumer surplus. And so what we can do is construct figures like this, where we plot out the average image payoff for each possible level of attendance. And there's 2 things to note here. One is that this is concave, right? Meaning that people are less sensitive to increasing positive image than they are to decreasing negative image. So that's bad. We would prefer it to be convex so that people are very sensitive to positive image and not so much to negative image. And what you can also see here is that the dashed red line here is the average level of attendance. And so the dashed red line, the image payoff is negative. These 2 facts together imply that overall, the social image intervention is a negative sum intervention, right? Because if image was 0 at exactly the average level of attendance and you have concavity, this is kind of a standard result analogous to how we think about risk aversion that would imply that already the average image payoff has to be negative just because of the concavity. But on top of this, the point at which social image is 0 is not even the average. At the average, it's already negative. And so together, this implies that it's actually quite a negative sum intervention. And so setting here, if you think about setting all of these targeting issues aside, this is an intervention that does not stack up so well, again, relative to more traditional policy tools like taxes and subsidies, depending on what you think are kind of what you think is the marginal value of public funds. But we have some calculations in the paper suggesting that the marginal value of public funds would have to be pretty high for the social image intervention to be more efficient than, say, an attendance subsidy. Yes.
Dmitry, I wonder whether with these kinds of arguments, you're being very generous to taxes and subsidies in the following sense. We know that there are behavioral issues with taxes and subsidies having to do with salience and the degree to which people understand them. You know that there's a lot of heterogeneity in salience. Therefore, using a tax or a subsidy is going to create a lot of variance in the response as well, which you seem to be assuming away.
Yeah, and I'll talk about the variance and salience tomorrow morning. So what I have in mind here is something more like, I think the kinds of syntaxes that Hunt was talking about, things that kind of very transparently affect prices, not kind of less conspicuous things. In the context of the YMCA, yeah, we probably don't want to structure it as a tax credit. That's the sort of thing where there are very heterogeneous responses and level of awareness and so forth. But maybe if it's kind of some salient thing that is as close as possible to just affecting people's membership prices, which people are kind of used to seeing and so forth. Yeah, I'm thinking a little bit on the fly, but you're absolutely right. So when we want to make the kinds of comparisons to incentives that I'm making, what we should really be thinking about is very, very simple to understand, totally transparent things that are analogous to excise taxes that directly affect the posted prices of products. Something that is more analogous to a sales tax that people don't see is going to lead exactly to the kinds of problems that Doug is talking about.
Sales taxes, we know, are not
Exactly.
salient.
Yes, exactly. Yes. Sugary drinks taxes, those are generally more like excise taxes that just affect the posted price directly. Yeah. Okay, so takeaways. NPIs I think are a little bit too popular because I think we sometimes perceive them as cheaper and more innocuous than they are. Instead, I'm not saying they're worse than taxes or subsidies. Rather the point I'm really making is they could be. There's lots of examples where they might be better, more efficient than taxes and subsidies, but we won't know until we basically treat them using theoretical and empirical approaches that are essentially the same ones that we use to very carefully scrutinize the efficiency properties of standard policy instruments. So it's all about careful modeling and measurement. And in terms of future work, what I would just say is there's a lot of work studying average treatment effects, and it's been a relatively successful industry. There's very little work that is actually studying welfare effects in the kind of way that I conceptualized here of these non-financial policy instruments. And so I think there's really tremendous opportunity for writing papers on these kinds of instruments that are specifically focused on welfare, and I hope you consider that. So I'll leave it at that, and then after break, Doug will do the second lecture on this. There's a question, yes.
Yeah, I guess I have a broad question about sort of short-term and long-term effects and comparing nudges to practice subsidies. This might be related to Michelle's question earlier. But I guess what I'm thinking about is sort of like Elizabeth and Dixitana have this recent paper about how, looking at the cross-mentioned units, like you look at the trials, it's like not significant. The effects are not as significant as previously referred to. And I guess I'm thinking, we're not unfamiliar with that, but I'm thinking more in the context of what you've been talking about, sort of like, is there any documentation within any of these contexts of like, attrition or like drop off by levels of bias, like differential drop off by bias level? And if there is, sort of what is the implication of that on sort of the welfare comparisons of something like a nudge versus?
Yeah, it's a really great question, which highlights, I think, two important things. One is it's actually very hard to answer your question because most of these studies do not have even proxy measures that can allow us to think about how treatment effects co-vary with bias. In some of these contexts, we might consider proxies like education, for example, where we might think higher educated people are making more informed, better choices, but it's not the strongest proxy. And then I believe the second thing you're highlighting is when we see that the average treatment effects in the larger scale RCT implementations are lower than in academic studies, should we be upset about that? And the answer is I don't know. Maybe in fact, the welfare effects, for all we know, could be higher in the large scale implementations than they are in the academic studies. And in fact, maybe the reason the average treatment effects are lower is maybe we're in the lucky state where these are well targeted. The academic studies somehow recruited people with lower biases. The story could be very different from the one we might infer if we're just looking at average treatment effects as a measure of success.
That's fine.